Thank you. So, good morning, everybody. Having discussed propositional logic and predicate logic and seeing the methods for trying to find out the validity of a propositional logic formula, we now come to inferencing using resolution refutation, a revolutionary method discovered by Alan Robinson, who defined this method as a procedure with a single rule and a single process by which we could solve the problem of deduction in predicate calculus. So, just to a quick recapitulation, in predicate calculus, we introduced the concept of variables, constant symbols, function symbols, predicate symbols, and two new connectors that exist and for all. And then we followed the same process by which we encoded our facts by formulae in first order predicate logic, and the goal by another formulae in first order predicate logic, and our objective was to prove that F1 and F2 implies G is valid. When we say something is valid, we mean that it is true under all interpretations. And the other day we saw what is the meaning of an interpretation in first order logic. An interpretation is more complex in first order logic because in an interpretation, for a single interpretation, you will have to start defining a domain, and then from that domain, so you have to define a domain, you have to map constants, you have to map predicates, you have to map functions. All these, which are symbols, have to be mapped, and you get one interpretation. And you have to now prove that it is true for all interpretations. Therefore, this gives us an infinite space to work on. So, how do we get to proving of validity in such an infinite possibilities of configurations is what we shall discuss today. But before we discuss that, we shall discuss, so for the method that we will discuss is called the method of resolution refutation. Because here we cannot draw a truth table which is finite because the space is infinite. Because this is infinite, we will have to follow a different procedure, and this procedure is called the method of resolution refutation. Now, in order to understand this method better, we will first solve this method using propositional logic. Before that, we quickly revise what is our inferencing. Our inferencing is about finding interpretations, and as we said, for every interpretation, we have to map it to a domain. We have to map constant symbols to elements of the domain. We have to map the function symbols to functions with the elements of the domain. We have to map predicate symbols with actual predicates assigning elements of the domain. And as we had seen, we could define an interpretation of this formula, which was our Merry formula. But as we have said before, that this Merry formula is just a structure because goes, merry, lamb, school, all of these are merely symbols. The meaning of those symbols are assigned when we assign an interpretation. Therefore, one interpretation could be a domain of some names. Another interpretation could be that D is a set of integers, and we could define M to be some 0, L to be some 5, S to be some 23, and then we can define the G function to be that Gxy is true if both x and y are odd or something like that. And we will see that whatever interpretation we do, this combination of formula which gives F1 and F2 implies G will be true for every interpretation. Similarly, a formula is said to be satisfiable if there is at least one interpretation for which the formula is true. We have also discussed a very important thing, that if F is valid, then not F is unsatisfiable. A formula is said to be unsatisfiable if it is false under every interpretation. A formula is said to be valid if it is true under every interpretation, and a formula is said to be false if a formula is said to be unsatisfiable if it is false under every interpretation. And we shall use this concept of negation of a formula in our method of resolution refutation. So we will first understand the method of resolution refutation in propositional logic. Before we move to predicate logic, we will understand the method of resolution refutation in propositional logic. So the steps are as follows, and please pay careful attention. To prove the validity of a formula of the form that we have, we will negate the formula and prove it to be unsatisfiable. Now the negate of F1 and F2 and so on and so forth implies G is F1 and F2 and so on and so forth Fn and not G. Because you will take not of A implies B can be converted to not A or B, and then you take the negate sign inside, and once you take the negate sign inside, you will get exactly what we want, and then when you negate the whole formula from outside, then you will get exactly this. So if anybody has a doubt that F1 and F2 and dot 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 Fn implies G, the negate of F is F1 and F2 and N and Fn and not G, please let me know. I hope everybody is convinced that if F is F1 and F2 and dot 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 Fn implies G, then not F is F1 and F2 and dot dot Fn and not G. Is that okay? Please confirm if that is okay with you all.
Yes, sir.
Okay. Thank you. If anybody has a doubt, let me know. Then here is the steps of the resolution refutation method. The first step is to convert the formula into clausal form. A clausal form is a formula which is in conjunctive normal form, or it is a product of sums. We know that we can represent a formula in sum of products form or product of sums form. When it is done in sum of products form, then each term is called a min term, isn't it? You remember in our circuit theory and all that? All of you remember? A, pro- a product of sums form is where it is each internal term is odd and every such term is ANDed. So a product of sums form is of the form C1 and C2 N dot dot and Cn, where each such Ci is some L11, Li1, or Li2, or so and so forth. So it is a product of some terms, or it is an AND of OR terms. So our first step is to convert this modified formula not F into product of sums form. And then the next step is to use what is called a resolution rule. By this resolution rule, we will have and we will see how we will form the resolution rule to really create our method. So before we go to that, we take an example. The example says that is our old example. If Asha is elected VP, then Rajat is chosen GSEC and Bharati is chosen treasurer. So these are our A, B, and C. Asha is elected VP, Rajat is chosen GSEC, and Bharati is chosen treasurer. My F1 was the first sentence, which was A implies B and C. My F2 was not B, and my G was not A. This is an old example that we have done. And we have to convert it to negate of F, that is our first step. Negate of F is F1, all the F1 to Fn remain the same, only we negate G. So we negated G. Now we convert to what is called clausal form. So the first formula converted to clausal form is like this. So I have, sorry, it is converted to clausal form where it is A or B and A or not A or B and not A or C. Now there are two clauses here. C1, which is not A or B, C2 is not A or C. Similarly, my F2 is not B, which is in clausal form itself, so this is C3. And my negate of G is what I use. If G is not A, my negate of G is A, which itself is in clausal form, so this is my C4. So by conversion to clausal form from the set of formulae, let me repeat, we were given F, we create not F, which is F1 and F2 and F3. Sorry, in this case it is F1 and F2 and not G. So in this case it is F1 and F2 and not G. This is what we have to prove to be unsatisfiable. Because the original formula is satisfiable, this is what we want to prove to be unsatisfiable. And the first step that we use is conversion to clausal form, which is a product of sums. And we have taken F1 and converted it to two clauses C1 and C2. C1 is not A or B, C2 is not A or C. F2 is not B, which is in clausal form. Negate of G is A, which is in clausal form. So now I have got four clauses. Anybody has a doubt at this point in time? Is this clear to everybody?
Yes, sir.
Okay. Then is the use of the resolution rule. The resolution rule is a single rule. It says the following. Given my set of clauses, which I have to prove to be unsatisfiable, suppose I have a clause C1, which is A or B, and another clause C2, which is not A or C, and I know that they are in product of sums form, so I know that C1 and C2 is true. Because they are in product of sums form and these are two clauses, all clauses are ANDed, as I just mentioned here. All my clauses are ANDed in this current representation. And because all my clauses are ANDed in this current representation, I know that in this case C1 and C2 is true. And because C1 and C2 is true, I can derive C3, which is B or C, and say that now along with C1 and C2, C3 is also true. Is it clear? Everybody?
Sir, sir, I didn't understand the last part. How from C1 and C2 is true?
So let us take two cases. Either A is true or A is false.
Yes.
All right. So suppose A is true. Then because C2, because C1 and C2 is there, if C1 and C2 both have to be true, then if A is true, if C1 is true and A is true, then C has to be true. Correct? Yes or no? Yes or no?
Yes, sir.
Similarly, take A to be false. If A is false, then for C1 to be true, B has to be true.
Yes, sir.
Therefore, B or C has to be true. So I can create a new clause C3 saying that if C1 is true and C2 is true, then C3 is also true. In general, if I have A or some subformula F1, not A or some subformula S2, and if this is C1 and this is C2, then and if C1 and C2 are true, then I can say C3, F1 or F2 is true. Is that clear?
Yes, sir. Got it.
Is that clear? Now, my resolution refutation method says, assuming that my initial set of clauses, n clauses are true, I will start saying that I will derive new clauses using this one rule. And as I go on deriving new clauses, I will see what situation happens. So let us do this for our current example. Our current example is this, where we have got C1 as not A or B, C2 as not A or C, C3 as not B, and C4 as A, as we had derived from here. Which we had derived from here. We had derived these four clauses from here. So once we come to this, we start applying the resolution rule. So what is applicable? C3 and C1 can combine to give what? Sorry, C3 and C1. So it will give C5, which is not A. And C5 and C4 will give what?
False.
False. Which says that C4 and C5 contradict each other. Now I came with the assumption that C1 is true and C2 is true and C3 is true and C4 is true. And assuming these to be true, I have proved that there is a contradiction. That means I have also proved that therefore C5 is true and C6 is true. But since C6 is false, therefore this whole formula C1 and C2 and C3 and C4 is false. And since this whole formula is false, therefore the set of clauses is unsatisfiable. And because the set of clauses is unsatisfiable, this formula negate of f, which was this set of clauses, is unsatisfiable. And because negate of f is unsatisfiable, therefore f is what?
Valid.
Valid. This is a toy method, which, again, to repeat my method, this toy method says that my method is like this. I will take f and I will convert it to negate of f, and I will try to prove that. Can you please mute all of you? There are close to 180 people in the class, so kindly mute.
Sir,
Yes.
how C1 and C3 give C5, sir?
What was? Did you understand the resolution rule? If C1 is A or B and C2 is not A or C, then C3 is C or B or B or C. Have
Yeah.
you understood that?
Yes,
Is that
sir.
understood? Okay, good. So C1 is not A or B and C3 is not B. So if not B is true and not A or B is true, then isn't not A also true? Yes, please.
Yes, sir.
Now you got it. Why C5 is not A?
Yes, sir. Okay, sir. Got it.
Anybody else has a doubt? Anybody else has a doubt? Good. Now, therefore, this is just the same thing expressed the way we discussed it, that I have my clauses, I produce my clauses, and then using my clauses, I prove it to be unsatisfied. Now, let us do this example, the example which we had done before. So, all of you, please quickly let me know what are my Boolean variables and what are my formulas. So please solve this problem quickly, all of you. What are my Boolean variables here? A,
Arjun is thin.
Arjun is thin. What is B? What is B?
Mohit is beard.
Mohit is bearded, let us say. What is C?
Julia is tall.
What is D?
Devika is pretty.
We have done this before. What is F1? What is F1?
A implies
A
is B bar or C bar.
What is F2?
C implies D.
What is F3?
D implies. Sorry.
No.
D,
D and B
D
implies A.
and B implies
Implies?
A.
What is F4?
B.
What is my goal?
Not C.
Everybody is with me on this?
Yes, sir.
Now my F, what is my F? My F is F1 and F2 and F3 and F4 implies G. This is my F. My not F is F1 and F2 and F3 and F4 and not G. What is not G?
C.
C. So now let us derive my clauses. From F1, what clauses do we get? What is the clause we
Not-
get from F1?
Not A.
Correct? What is the clause that we get from C1? Somebody please tell.
Yes, sir. This is not A plus not B, or not B, or not C.
Or not C. What is C2?
Not C or D.
Not C or D.
What is C3?
Not D, or not B, or A.
What is C4?
Just B.
What is C5?
C.
C.
Is it clear to everybody that these are my 5 clauses? Anybody has a doubt? Does anybody have a doubt up to this point? Shall I proceed?
Yes, sir.
Yes,
So
sir.
now tell me how new clauses can be derived. Tell me one way. Tell me one step. There are many options, but tell me one. My resolution rule is A or B,
Sir, C2 and C5.
C2 and C5. C2 and C5 will give C6, which is what?
D.
D.
Is it clear to everybody that I'll get D here?
Yes, sir.
Then tell me another one.
From C1 and C4 and C5.
No,
we will...
you take two together. Take two together. Then you can say everything I will take and get false. Then nobody will understand. Take a pair and derive a new
From
clause.
C1 and C4, we can get not A or not C.
So C1, from C1, using C1 and C4, I can get C7, which is what? Not A or
Not C.
not C. Good. So I have got C6, I have got C7. What else?
C1
What else?
and C5, we can get not A.
C7 and C5.
C7 and
Sorry,
C5.
C7 and C5 actually. Yeah.
Do one by one. Do one by one. Take one clause at a time. Take one literal at a time. So C7 and C5 you want to do what?
get not A.
Not A, yes, C7 and C5.
C5.
So C7 and C5 will give me C8, which is not A. Is it clear to everybody? Is this clear to everybody? Anybody is lost out in what we are doing?
Yes, sir.
Next,
C3 and
C3 and
C8.
C3 and C8 will give me C9, which is what?
Not D
Not
or
D or
not B.
Not D or not B. Then
C9 and C4 will give not D.
C9 and C6
Yeah, okay.
will give C10, which is what? C9 and C6 will give C10, which is what?
Not B.
Not B.
Not B.
And then C4 and C10 will give me C11, which is
False.
false. There are other ways. This need not be the sequence. There are other sequences possible also, but this is one sequence. So all of you, please pay attention. Anybody has a doubt, let me know. Please look at this, and anybody who has a doubt, let me know.
Sir,
Yes.
sir, earlier we saw that we use this method when we know that it will be valid, the uh, proposition.
Yes.
Sir, so if that's why we were keep on going to find new C because we knew that we'll get this condition of false,
Correct.
right? Okay. Oh, yes. Okay.
Now, let us continue on your question. Continuing on your question, if by doing this we go on doing and we are in propositional logic. In propositional logic, we continue to do this, and while we continue to do this, we may end up in a situation of false. But if f is not valid, that means not f will be what? If f is not valid, then not f will be
Satisfiable.
not f will be satisfiable, and therefore if not f is satisfiable, false will not be generated. And if false is not generated, then while you derive new clauses, because it is a finite space, after some time you will not be able to derive any new clause, nor will you be able to prove a false. That means you will neither reach a contradiction nor any new clause will be derived. At that point in time, I leave it to you to determine that it will not be difficult to find a satisfying assignment. So, if the situation arises that you are not able to find a contradiction and no new clauses are generated, then the formula is satisfiable, which means that the original formula f is not valid. How to find a satisfying assignment? That I leave it to you for an exercise.
Sir,
Yes.
sir, here, sir, we are using C1 and C4 to find C7. And sir, again, we are using C4 and C10 to find C1. Sir, how can you use C4 two times here? Because C4 is used in C7 once.
So why you cannot use it?
Sir, there So taking two clauses to make one new clause in first step.
So that's all right. But nobody has told me that I cannot use this to make another new clause. Suppose I have three clauses. One is A or B. One is A or C, and I have not A. Then can I, from using these three clauses, using A or B and not A, I will derive B. Using A or B and not C, A or C and not A, I will derive C, isn't it?
Yes, sir.
So nobody prevents me. It's just ANDed. They are all ANDed. AND is a commutative associative operator.
Yes, sir. Yes, sir. Understood. Thank you, sir.
So the method, I repeat, is negate the formula, convert to clausal form, use this single resolution refutation rule. The unique thing of this resolution refutation rule is that it is sound and complete. The single rule for Boolean logic says that if you derive false, it is correctly derived, and if false can be derived, it will be derived. So this was the beauty of this in resolution refutation. But the power of resolution refutation comes not from propositional logic. We did propositional logic as a play exercise for us to understand the actual thing. So now we move to predicate logic. So, yes.
So can you once again explain, like, I did not get what you mean by sound and complete.
A method is said to be sound. Here it is sound, it says that if the formula, if false can be derived, two parts are there. If the resolution sequence of resolution rules derives it to be false, then the formula is false. Is it understood?
Yes, sir.
This is called soundness. Soundness of a method says that if the method derives something, then it is correctly derived. Completeness says if false can be derived, it will eventually be derived. One is an if condition, the other is an only if condition. Is it clear now?
Yes, sir.
So now we come to the real fun part. The fun part says that now what do we do for predicate logic? In predicate logic, we have variables, we have function symbols, we have constants, we have propositional symbols, we have predicate symbols, we have for all, we have there exists. Now, because we have all these things, our method remains the same. Our method says, given a formula f for validity, we first check whether there are any free variables. And if there are any free variables, we quantify them by a for all. So suppose I have a free variable, then I assume that it is universally quantified. So we put universal quantified at the absolute outside. Then we negate the formula. Then we negate the formula. We negate the formula and create f dash, which is negate of f. And then again prove that this f dash is unsatisfiable. The basic approach is the same, except that because of variables, if there are any free variables, then we universally quantify them by a for all outside. Then again the same two steps: conversion to clausal form and applying the resolution rule. But now, because we have this whole concept of variables and quantifiers and constants and predicates and propositions and functions, our conversion to clausal form is a little more intricate. Similarly, our resolution rule is also a little more intricate. And we shall now start understanding them more carefully. So how do we? Here are the 6 steps to be sequentially applied for conversion to clausal form in predicate logic. The 6 steps to be applied sequentially to convert to clausal form in predicate logic. First step: remove implications and other Boolean symbols and leave aside the formula only in terms of not or and. So the first step is to remove all other symbols appropriately by converting them into the equivalent not or and forms. The second step is to move the negate inwards. And which rule shall be used to move the negate inwards? By which rule? By which rule shall we move the negate inwards?
De Morgan's law.
De Morgan's rules. We have done that if we move it inside, for all becomes their existence, so on. Then is an important step. We had discussed that because the variables may be ambiguous, we would like to remove the ambiguity because of the scope rules and standardize the variables. And after we standardize the variables, we make them unambiguous. Then comes the most important step, is removal of existential quantifiers, and we shall come to that in a bit. And how we remove those existential quantifiers, we shall come in a bit. But before we go there, we shall understand a few more things a little carefully. Then is drop the universal quantifier. So we have removed existential quantifier, which means that every variable now is universally quantified. So we drop the universal quantifiers and we assume that every variable is universally quantified. Then we apply the distributive law. So these 6 steps: remove implication, move negates inwards, standardize variables, remove existential quantifiers, drop universal quantifiers, distribute. Let us see our example of Mary Lamb. To prove this, we will have to prove F1 and F2 and not G to be unsatisfied. So our first step is to make the negate of the formula. Now, let us apply our method on F1. On F1, if we have to apply our method, we have to remove implication and other Boolean variables. So my formula F1 will now become for all x not goes Mary x or goes lamb x. Is it clear to everybody?
Yes, sir.
My F2, because these are two constants, for a formula which has only constants and predicate symbols, and function symbols and no variables are called ground instances. So this will become goes Mary school. What will not G become? What will not G become?
Not of G, I mean goes lamp school.
So this is my C1, this is my C2, and this is my C3. This is C3, this is C2, and this is C1. This is a simple example where we did not require to apply many of the steps, especially step 4. We shall come to application of step 4 when we come to our more details. Is this point clear, everybody?
Yes, sir.
Now we quickly look at the generalization of the resolution rule. The rule remains the same. That means if I have two clauses with a literal in its positive and negative form, in its positive form in clause C1 and negative form in clause C2, then I will apply the resolution rule to derive a new clause. But in order to do that matching, I may have to look at my variables and my constants and see whether the variables and my constants are matching each other or not. And since some cases there may be variables and some cases there may be constants, in order to create a match, I may have to apply a substitution. For example, if I look at F1 and F2 here, then which literals are matching for resolution? Not GMX, where X is a variable and M is a constant, and GMS, because where M is a constant and S is a constant. And one is a negate of the other. So here F1 and F2 can match provided we substitute F1 in X by what is the substitution we have to apply to X?
S.
S. If we substitute X by S, then F1 becomes not GMS or GLS. And now by applying resolution rule, I will create a new clause C4, which will be what?
GLS.
Is this clear to everybody? In F1, I substitute X by S and then apply the resolution between C1 and C2, and I create C4, which is GLS. Anybody has a doubt at this point?
No, sir.
Good. Now I can combine C3 and C4 because there are no variables, both are ground instances like predicates, and I will get C5 to be
False.
False. This is a trivial example, but definitely this example is just our starting point for us to move ahead into what we really need to do. Anybody has a doubt up to this point? Shall I proceed?
Yes, sir.
Okay. Now, this substitution and resolution rule application is known as the process of unification. This substitution and application of the resolution rule, so this substitution is also called unification. Unification is not as trivial always as I have pointed out. So let us see some examples.
Sir,
Yes.
could you please explain how you wrote C1 as XOR S?
C1. You want to ask me how I wrote C1 like this? Not GMX or not GLX? Is this your doubt?
No, sir. How you wrote C1 as XOR S? I didn't understand that.
Where I wrote C1 as X or S? This is not OR. I'm substituting X by S. Substitute variable X by constant S in F1, in C1. If I substitute the variable X by a constant S, because it is universally quantified, therefore it is true for all X, therefore it must be true for the constant S, isn't it?
Yes, sir.
So then if I do that, then what will I get? I will get not GMS or GLS. Isn't this what I will get if I apply that substitution?
Yes, sir.
And then if I do resolution with C2, will I not get C4?
Yes, sir. Understand, sir.
Okay, good, good, good. So now let us understand a little more carefully these ideas of unification. To understand a little more carefully the idea of unification, let us take these four clauses. So now C1 and C2, what can I derive? From C1 and C2, what can I derive?
Passes. Right.
What can I derive? I can derive passes Madan, physics. Can I derive passes Madan, physics? Can I derive passes Madan, physics?
Yes, sir.
Because to do that, I will have to substitute X in C1 by Madan and Y in C1 by. So I will substitute here, substitute in C1 X by Madan and Y by physics, and substitute in C2 Z by what?
Physics.
Physics.
Physics. I can also derive passes modern mechanics. Correct?
Yes, sir.
Yes, sir.
I can also derive passes modern Chetan. It looks odd to you, but nobody told me that Chetan is somebody's name, right? It's a symbol only. I could have written it as abracadabra also. Here, these are all symbols. I could have also replaced it, derived passes Madan. Is it clear to everybody? Nobody prevents me from saying all this. Now, can I write down C7 as same as passes Chetan physics? Can I derive this from C1 and C2?
No, sir.
No, sir.
No, sir.
No.
No, sir.
Why? Because C2 has Madan in the first argument and I cannot replace a constant by another constant. But are these C3, C4, C5, C6, are these, which is the best way to replace, to resolve C1 and C2? What should be my most general resolution?
Passes Madan Y.
Passes Madan some W, where W is a variable and this whole clause is universally quantified by W, which means that C8 is meaning for all W passes Madan W. And I am saying that this is more general than C1 to C3 to C6.
So we are using W for another variable as well. So will it create an issue?
No, it is for all W. Na? These are all universally quantified. I have removed existential quantifiers and every variable is universally quantified.
Okay.
So my most important thing is that I must resolve by the most general unifier. When I resolve by the most general unifier, then I create the most general new clause. And this is a critical step in my method of resolution refutation. Now let us see. If I resolve this and this, C1 and C3, what would be my most general resolution?
Not
studies
studies.
Chetan X.
Not studies, Chetan. Chetan what?
Physics.
Physics. Here, here both are there. I cannot replace a constant by a variable. That will lose the meaning. This C3 says not passes Chetan physics. It does not say not passes Chetan Y or not passes Chetan W. So my substitution in the first, in these two, in X will have to be substituted by Chetan and Y will have to be substituted by physics. And this is my correct derivation. Everybody understood? Is it clear to everybody?
Yes, sir.
Now let
Yes,
us
sir.
do C1 and C4. What will be my most general solution of C1 and C4?
Not
Not
studies,
study.
X mechanics.
So not studies X mechanics is my most general unification mechanism. So that is very important. That is very important. Is it now clear, everybody, about substitution, unification, resolution? These three things: substitution, unification, resolution. I am moving on. So now I come back to my original steps. In conversion to clausal form, these were my 6 steps. Now these 6 steps will be used for more complicated formulae, especially when I come to this part. Especially when I come to this part, and we shall see them first through examples and then to the general rule. We have not yet seen how to remove existential quantifiers, etc. So let us do another example. Our contractor wala example. So we come back to our contractor wala example, which we had done before, which talks about what are the English sentences? No contractor is dependable. Some contractors are engineers, and my goal is some engineers are not dependable. Remember, everybody remembers this.
Yes, sir. Yes, sir.
So now, from F1, what do we derive? By applying the clausal conversion. So here again, I have to do F1 and F2 and not G, and I have to prove this to be unsatisfied. So this F1 and F2 and not G, I have to prove to be unsatisfied. So what happens to F1? What does F1 become? What is the clause I get from F1?
For all x,
Yeah, after for all x, I will remove the for all, so it will become not.
not of contractor x or not of dependable x.
Is everybody okay on C1? Now comes my C2. Here is where Is everybody okay on C1?
Yes, sir.
Now look at C2. Now, when I come to C2, I have to invoke this step. My steps were remove implications, there's nothing to do. Move negates inwards, nothing to do. Standardize variables, nothing to do. Remove existential quantifiers. Remove existential quantifiers. That is the most important step that I need to now do on this F2. So now what my method is, if there is an existential quantifier, that means I have something of the form there exists x px, then I replace it by a new symbol PA. It says that since there exists x px, I create a new constant symbol A and designate that constant symbol A to be that person for which there exists x px is true. So this is my first step. It is a little more complicated, but it will work for this simple case that we have handled now. That is, if I have some there exists x px, I will replace it by PA. We now come back to our C2. Our C2 is derived from F2, which says there exists X, engineer X, and contractor X. To do that, I will choose a new constant symbol A and form engineer A, and convert F2, this is F2, I will convert F2 to engineer A and contractor A. Given there exists X, engineer X, and contractor X, I will choose a new constant symbol A and form engineer A and contractor A. Clear, everybody? And because it is ANDed, I will get two new clauses, C2, which is engineer A, and C3, which is contractor A. So I have C1, I have C2, I have C3. Anybody has a doubt at this point? Anybody has a doubt? Clear to everybody?
Yes, sir.
Now what is the next step? Which is the next one? I have done F1, I have done F2. I've got three clauses till now. Which one I have to do next?
G is
Not G.
not
Not G. So what is negate of G?
negate of G will transform there exists to for all, so we can
This will become for all X. What will it become?
for all X
For all X, not of E of
not
X
X or
or
dx.
D of.
And in order to convert this, because this is for all and this is already in clausal form, so my C4 will become
not EX or DX.
Good. So now I have got these four elements. Now I have got these four elements. C1, which is not CX or not DX. C2, which is EA. C3, which is CA. And C4 is not EX or DX. Now what I can resolve? What are my resolution stuff that I can do now?
C1 and C3.
By C1 and C3 yields C5, which is what?
Not of DA.
Not of DA.
So I get not of DA. Then what else can I do?
C5 and C4.
C5 and C4 yields C6, which is?
Not of EA.
Not of EA.
And C6 and C2?
False.
False.
C6 and C2 give false. So here we had to apply the removal of the there exists. And by applying on the removal of the there exists, we replaced it by a new constant symbol. This is not as simple as this. It is a little more intricate, and we will come to that intricacy in a while. This sort of conversion is known as scholemization. It comes from the person who first proposed it, called Skolem. And once we see a little more details of that, we will understand what is the importance of it. But before we move on to that importance, I will ask you all to solve this on your own just now. All of you, please solve this problem on your own.
Sir,
Somebody had a question?
Yes, sir.
Huh?
If we have more, what do you call it? Statements with existential quantifiers, then
No,
each
first we'll
time we
solve this problem. Please solve this problem,
okay.
then we'll answer those questions. So please solve this problem, then we'll answer all those questions. Anybody who has solved the problem?
Yes, sir.
Yes, sir.
Yes.
Yes.
So tell me, what is C1?
Not of dancer of X or graceful X.
What is C2?
Student Ash.
What is C3?
Dancer Ash.
What is C4?
Not of student of X or not of graceful X.
Has everybody got these 4 clauses? Anybody who has not got these 4 clauses?
Yes, sir.
Anybody who has not got these 4 clauses? Anybody who is lost here? Everybody is fine?
Yes.
Shall you say yes? Okay. So tell me, what is C5
C1.
and how does it come?
C1 and C3.
C1 and C3 we get GA.
Graceful of Ash.
Then C6.
C2 and
C1
C4.
and C4.
C6.
What is C6 comes from?
C4 and C.
C4 and C5.
C5. It is coming as not of SA.
Not student of S.
And C8, C7 is?
C2 and finally C. Not of SA, I will give you false.
Are we all okay up to this point in time? Anybody has a doubt now up to this?
Sir, I have done with C2 and C4 and again C5,
Yeah,
C1.
some other sequence
Yeah.
you can get.
Yeah, yes, sir.
Doesn't matter.
Somehow we got five.
Yeah, you
false.
can get many sequences. You can get many sequences. But you will get false.
Okay, sir.
Anybody has a doubt? Otherwise, I will proceed. Now, I'm moving on to a different format. If I have there exists X, there exists Y, PXY, what is the clause that will come out of this?
P of A comma B.
P of A comma B. Is it clear to everybody?
But so we can have A and A also, right?
A and A if you have, and because these are symbols, then your interpretations are restricted. If you have A and B, then you can interpret A and B to the same element of the domain, and you can also interpret A and B to different elements of the domain. But if you write only PAA, then you are not conveying the full meaning of the sentence there exists X, there exists Y, PXY. Is that clear?
Yes, sir.
So that is why it always says new. Good. Let us do another one. There exists X for all Y, PXY. What will this become?
P of
A
A comma Y.
It will become P of A comma Y. Is it clear to everybody that it will become P of A comma Y? Everybody, is it clear?
Yes, sir.
Yes, sir.
Let's do another one. For all x, there exists y, P of xy. What will this become?
P of x comma
P
a.
of
P
x
of
comma
x
f.
comma a.
P of x comma a. Is it true that it will be P of x comma a?
Sir, it has to be something different because else the order doesn't matter in this case.
Ah, what you have written here, P of x comma a, this is actually for the formula. What? Tell me.
There exists y for all x. Pxy.
P, there exists y for all x, like we have done the one before here. There exists y for all x, pxy will be pxa. There is somebody, you go back to your likes definition. This one says there exists y for all x, pxy. What is the sentence? It says there is someone who is liked by this sentence. There exists y. Let us call this as the formula x. This formula x, what is its English format? There is someone
Who is liked by everyone.
who is liked by everyone. Is it clear to everybody?
Yes, sir.
Whereas this sentence says, this
Everyone
sentence
likes
y
someone.
says,
Everyone likes someone.
everyone likes someone. Are these two the same?
No, sir.
No.
So, to do this one, we have to replace y by a
Function of x.
function of x. So here, for doing this, replace y by a new function symbol of x. So this will become p what? X pay very careful attention. The difference between this one and this one. It says the first one, X, says there is some person, and this person is the same person liked by everyone. So that is why I have replaced it by PXA. But the second one, which is Y, capital Y, it says capital X can be replaced by PXA. But capital Y requires that for every X, the person that X likes is dependent on X and can vary. So we replace it by a function symbol of x. Try to understand this very carefully. This is very critical. That is why this is called a Schoolem function, not necessarily a constant. Anybody who has not understood, tell me. Clear? Everybody clear?
Yes, sir.
Shall we do some example? Let us do another example. Let us do another example. For all x, there exists y Px, y implies qy. How will I replace it? What will be its replacement?
P of x comma f of x implies q of f of x.
Yeah, what will be the clausal form?
Not P of
First,
x comma f of x.
Not P of x comma f of x or q of f of x.
F of x.
all right, everybody? What will this become?
Not of P of x comma f of x or q of f of x comma g of x.
That means x, y is a function of x, z is a function of x. And those two functions need not be the same. If I want to do this conversion in an appropriate manner. Anybody who has not understood? Anybody who has a doubt, please let me know. Is it clear to everybody? Let us do another example.
Sir, actually, so g of x will be g of f of x, but since f of x is already function of x, we will replace it with g of x only.
It's a two different functions. There is z is dependent on x and y is dependent on x. X and y are not dependent on each other.
Yes, sir. Y and z are both dependent on x, so
Yeah, so two different functions.
sure.
They need not be the same function. They should not be if I want to do an accurate conversion.
Sir,
Yes.
in second one can be encoded to someone likes everyone in the previous slide.
This one?
In previous slides, sir.
Which one are you talking about, x or y?
Second one, sir. There exists x for all y. Can we encode it to someone likes everyone?
If I have defined likes xy as x likes y, then how can you write this as someone likes everyone?
Okay.
It is not commutative. Likes xy implies x likes y is not told to me.
So what we should say for this one? For there exists x for all y.
I have written it down here. Can you not read?
That is for third one, right, sir?
One is called capital X, one is called capital Y. Which one are you talking about?
Above capital Y.
Above capital Y. So let us call this capital Z. What is this sentence saying?
Sir,
This sentence says someone likes everyone.
Yes. Okay. Thank you, sir.
What happens to the one I have now?
Function of both x and y.
X and y.
Yeah. So let this be f1, let this be f2, let this be f3. So now tell me what will be the formula for f3?
Not of p of x comma y or q of y comma f of x y, x comma y.
Everybody agrees that this x, this z is now governed by both x and y. This z is now governed by both x and y. Anybody has a doubt up to this? What does this become?
So y will be a function of x only, and w will be function of x and z.
Yes. So tell me what it will be. E of x
as a function of x.
Some fx. Yeah. Then
Z.
Z. Then
P of x and z.
g of
X and z.
a different. I cannot write f again. I have to write g of x and z. Anybody has a doubt? Now let us come to f5. So, so What happens to this one?
W and Y both will be functions of X.
So tell me what will be the answer.
So not of P of X comma F of X or Q of G of X.
Is this clear to everybody?
Yes, sir.
What will happen to this one?
The inside y is replaced by a constant. Second y, I think.
No, sir, both will be different function of y, x, I think.
Same as
So
the before.
here
It will be same
we
as
have
above.
to, yeah, it will be same as this. Why? Because there is one more step which was there before removal of existential quantifiers. What was it called?
Remove ambiguity.
Whenever there is a confusion in the scope, rename the variables. Because this y is for this and this y is for this and their scopes are different, so I will replace this y by some z. Is it clear to everybody?
Yes, sir.
So now we go back and revisit our main steps in conversion to clausal form. Is remove the implications, move negates inwards. We saw an example where we needed to standardize the variables to make them unambiguous. Then is this famous step called scholemization. Where we have seen all the nuances of scholemization till now. Then drop universal quantifiers, then apply distributive law. In order, after doing all that, we go back to our resolution rule, and in the resolution rule, our method is find the most general unifier, and after we find the most general unifier, we then continuously apply only the most general unifier rule. If you apply a lower rule, you will get into trouble. Just some finer properties. This example you all do, because this example which I have done for conversion to clausal form, I think I have done it in the pre-recorded video also. But certain properties. Resolution, refutation for predicate logic. It is sound. which means that if I derive false, it is correctly false. But it is partially complete. Partially complete means that if false can be derived, it will be derived. But if false cannot be derived, the algorithm may not terminate. In the propositional case, it was sound and fully complete, which meant that if false could be derived, it will be derived. If false cannot, so if false is derived, it is correctly derived. The other part is if false can be derived, it will be derived. If false cannot be derived, the algorithm will stop without deriving false, from which you can get the satisfying solution. But here it says that if false can be derived, it will be derived. But if it cannot be derived, if it means false, cannot be derived, the method may or may not terminate. This is because the problem by itself is undecidable. Predicate logic is equivalent in power as a Turing machine. And we know that there are problems which are undecidable. So there are undecidable problems. This is the complexity of the problem itself. It has nothing to do with the algorithm. A problem is said to be undecidable if there is no algorithm ever which will be able to solve that problem. And there is a proof that there cannot be an algorithm that will solve that problem. So, which is the most practical, undecidable problem that all of you have faced? Can you tell me? All of you have faced one problem. Anybody who has done programming has faced one problem which is undecidable.
Detection of infinite loop.
Yes, detection of infinite loop. Till now, you have all the most intelligent people of this world have written so many programs. Why has anybody till now not been able to write a program which can take as input any program and tell me, and the input to that program, and tell me whether this program will go to infinite loop or not, without the detector itself going into an infinite loop? The reason for this is that such a problem is not possible to write. How many of you have not heard of this problem? How many of you have not heard of a problem that can be undecidable? Please raise your hands. Anybody else? Okay, we will discuss this in more details in tomorrow's class. That there are problems which may be undecided. And one of the problems is to be able to detect infinite loops. That means, can we write a program which will take as input any program and make sure that this program and detect whether this program on this input, so it will take the program and the input, or maybe these are all programs which don't take any input, it just runs. But you have to just take the inputs are given in the program, you have to just take this as input and detect whether it will go into an infinite loop or not. And this is equivalent to what is also known as the halting problem. And we will also discuss this in the context of another problem that I had shown in the previous class. What was that called? Russell's paradox. So we will look at it from that point of view. That is why resolution refutation is partially complete. It says that whatever, if it derives false, then false is derivable. If it stops with deriving without deriving false and no new clauses can be derived, then you can prove that this formula was satisfiable. The other part is that if false is possible to be derived, it will derive it. But if the formula is satisfiable, this algorithm may or may not terminate. So with this, we come to the end of this class, where we have discussed in details the resolution refutation rule. It is one of the most landmarking methods in logic, for which Professor Robinson got the highest award in computing, which is called the Turing Award. Any questions? Otherwise, we'll stop today and continue. We will have our tutorials in the second half at 5 p.m. Please come so that we can solve problems by resolution refutation. And we'll have our final class on this topic tomorrow to wrap up any doubts and some of the open issues. Any questions?
Sir?
Yes.
Sir, when we are using the method in case of propositional logic, when it was not possible to prove that it is false, we are terminating by checking if any new clauses are being generated or not, right?
Right.
So, sir, suppose I have already generated C1 through Cn clauses. And now I have to wait till I check all possible NC2 combinations.
Yes.
Okay.
You will stop when no new clause is derived by checking all possible combinations that can still derive clauses. You will see that nothing new can be derived. Whatever has to be derived has all been derived. The set of new clauses will not increase. It's if you look at it as a set.
Okay, sir.
Good. Okay, thank you for your attention. You can stop the recording and then we will